Okay, so our problem says a factory can make jeans or trousers. Each pair of jeans takes 3 hours to make, trousers take 2 hours. There are 90 working hours available per day. Each pair of jeans costs €10 to produce, and each pair of trousers 15. There is a budget of €600 per day available. A pair of jeans gets a profit of €8 and trousers get €6. How many of each to maximize profit? Okay, so basically we can do the problem with two methods. Either one graphing it, but it wouldn't be as accurate, but I have a video of this problem solved with a graph, and it obviously wasn't as accurate. And now we're going to do it in the second method, which is actually doing maths, not graphing it. So what I mean by this is we're going to get the maximum number of jeans and trousers we can make to maximize the profits. So what are we going to do? We're going to call the number of jeans, we're going to call them X, and the number of trousers, we're going to call them Y, as I have here. So what are we going to do is we're going to say, okay, so each pair of jeans takes 3 hours to make. Okay, so it's going to be 3 hours to make by the number of jeans. What's the number of jeans? X. Okay, so we're going to call it 3x. So 3x is going to be the number of jeans we're going to make, and it takes 3 hours to make them. So it's going to be 3 hours to make each pair of jeans. So it's going to be 3x. Plus 2 hours to make each pair of trousers. So it's 2 hours by the number of trousers we're going to make. So it's y. Y is the number of trousers. And this is going to be, it has to be less or equal than 19 working hours. 90. Okay? Which means that is that the number of jeans, it takes 3 hours to make the number of jeans, okay? And it takes 2 hours to make each pair of trousers, and the addition of them has to be less or equal to 90, because that's what it says in the problem, right? So second of all, we're going to have another equation. What's the equation? Right, well, it says that each pair of jeans costs €10 to produce, okay? So it's €10 to produce each pair of jeans, so it's going to be €10 by the number of jeans we're going to produce, plus €15 by the number of trousers we're going to make. So if we make 2 trousers, it's going to be €15 by 2. Y is the number of trousers, but we don't know the number of trousers yet. Neither we do of jeans. So that's why we call them y variables, X and Y. And this has to be less or equal to €600 a day, because that's what the problem says. There is a budget of €600 per day available. Okay, so if we get back to it now, we have two equations. How can we solve them? Well, we can solve them with a graph, as I did in the other video, or we can solve them with simultaneous equations, right? So what we do is we're going to pretend they're equal, and we're going to find the maximum. We're going to try to find the max. We're going to try to maximize the profit. So what we do is, okay, how do we do? Well, we want them to equal. So we're going to do there's 2 ways to do it. We're going to use the simplest one here. So we're going to multiply this row by 10 and this row by 3 to make them equal, because we want 3x and 10x to be equal, right? So we do them again. This will be, the first line will be 30x plus 20y is equal to 900. And the second one will be 30y plus 45y is less or equal than 1,800. Okay, now they're equal, but we want them to equal, but with different sign. So we're going to change the sign on one of the lines. So we're going to change the sign on this one. So we're going to make this minus, minus, and minus. Now that these ones here are equal, but the opposite sign, now we can do the operation. So we're gonna add them up. So 30x minus 30x is 0x. So we don't have to put it in, but I'm gonna put it in just for the sake of easiness. Then we're gonna have 20y minus 45y minus 25y, and this is equal to minus 900. 900 minus 1,800 is minus 900. So now we can get rid of the signs here, plus and plus. So we're going to have 25y is equal to 900. Okay, and now what we do is we bring then 25 dividing. So we say that y is going to be equal to 900 divided by 25 is equal to 36. So the number of, y is the number of trousers, as we said. So the number of trousers we can make is 36. Okay, well, now we have the number of trousers. Okay, we have the value y. So what do? We go to one of the equations. Let's say the first one, put it as equal 90, and we know the value of y is now 36. So what we do is 3x plus 2 by 36 is equal to 90. Okay, so we have 3x is equal to 90 and 2 by 36 is equal to 72, and I'll bring it to the other side as a minus. So now we have 3x is equal to 18, so x is equals to 6. 1 and 2. So now we know that the number of trousers we can make is 36 and the number of jeans is going to be equal to 6. So to make sure this is the correct answer, what we're going to do, we can double check it. How do we double check it? Okay, well, this is very simple. If we say that let me just make a square here. So we say that we're gonna make a profit for each pair of jeans. I'll highlight it here. For a pair of jeans gets a profit of €8 and trousers get 6. So jeans get a profit of €8. So jeans 6 by 8 is equal to 48. And then 36 by the profit of 6, 36 by 6 is going to be 216. We add them up and we get 264. This is the money they're gonna make of profit. Okay, it's not asking you the money, how much profit they're gonna make, but just how many would you need to maximize the profit, and this is it. Okay, this is the most accurate way to do it with a graph, as in the previous example I made in my previous video was making a graph and the exact same problem, and I got 37 and I got 8, I think. So it's not as accurate, because there's like a minimum margin of error we can have, you know, when the pencil is not, you didn't do like proportional right, or we didn't split the graph in different sections, or a variety of different margin of errors we can get. So this is the most accurate way. But if you ask to do a graph, you graph it and you try to get the most accurate way, and this is the way to check it.